Humanity's first math was not about symbols or proofs. It was survival. Tally marks in bones, pebbles in piles, knots tied in ropes. Every mark meant something. A goat counted. A basket of grain tracked. The Ishango bone, carved more than 20,000 years ago, shows early humans weren't just counting. They were already noticing patterns, group of numbers, even hints of multiplication. Math began as memory outside the brain, a way to carry knowledge across days, seasons, and generations, just the difference between life and death. Then came civilization. Villages became cities. Cities became empires. And with them, math had to grow. In Egypt, geometry was born out of necessity. Every year, the Nile washed away farmland boundaries. Farmers and scribes used math to redraw them. The same geometry helped architects align massive stones in pyramids, so precise that modern lasers still marvel at this accuracy. In Babylonia, math jumped forward again. Clay tablets reveal base 60 numbers. That is why we still divide time into 60 minutes and circles into 360 degrees. They could already solve quadratic equations and chart stars with trigonometry-like methods. In China, mathematicians worked with linear equations, magic squares, and astronomy. They created systems to predict eclipses, map calendars, and guide imperial projects. Math was no longer survival. It was now the infrastructure of empires. Taxes, trade, agriculture, astronomy, architecture, it all depended on numbers. Around 600 BCE, the Greeks turned math from a tool into a philosophy. Pythagoras believed numbers held mystical truth, that the universe itself was structured in harmony. His famous theorem was more than triangles. It was the belief that reality could be measured. Euclid wrote Elements, a masterpiece of logic. Not just answers, but proofs. A system built from axioms showing that math wasn't just calculation. It was reason itself. This book would educate mathematicians for over 2,000 years. Archimedes pushed math into engineering. He calculated volumes, areas, and centers of gravity. He invented war machines and imagined concepts that foreshadowed calculus. For the Greeks, math became the language of truth. The first golden age of mathematics was shining. But golden ages don't last forever. Rome rose, then crumbled. The great libraries of Alexandria burned. Manuscripts were lost. What survived was scattered across monasteries, hidden in fragile scrolls. Europe slipped into centuries of stagnation. Commerce used numbers. Cathedrals rose with geometry. Calendars ticked forward. But the great momentum, the exploration of new math, slowed almost to nothing. For nearly 1,000 years, Europe's mathematical brilliance was dimmed. It was as if math itself had fallen asleep. Yet, while Europe stumbled, math didn't die. It thrived elsewhere, quietly, steadily. Indian mathematicians invented the concept of zero, a small circle, yet one of humanity's greatest ideas. Along with it came the decimal system, making number easier, more powerful, more scalable. In Baghdad, Damascus, and Cordoba, knowledge flourished. Al-Khwarizmi, the father of algebra, gave us systemic method for solving equations. His name gave us the word algorithm. Trigonometry advanced for astronomy and navigation. Omar Khayyam worked on cubic equations and contributed to geometry. Scholars preserved Greek texts and expanded on them, ensuring they weren't lost forever. Slowly, through translation in Spain and Sicily, this knowledge crept back into Europe. The flame had not gone out. It was just hidden, waiting to ignite again. And when Europe awoke, it wasn't gradual. It was explosive. Art, science, exploration, all demanded mathematics. Artists like Da Vinci used geometry to invent perspective, turning flat paintings into windows of depth. Explorers crossed oceans with trigonometry. Galileo proved motion could be measured. The Book of Nature, he said, is written in the language of mathematics. And then came the thunderstrike. Isaac Newton discovered the mathematics of change. With calculus, we could describe orbiting planets, flowing rivers. For the first time, humanity had a universal tool to capture motion itself. Math was reborn, and the modern world began. Probability and statistics emerged from gambling and science, letting us measure chance, risk, and uncertainty. Euler introduced notation and solved problems across geometry, algebra, and calculus. Einstein used geometry to bend space-time itself, giving us relativity. Quantum mechanics relied on probability and linear algebra to explain particles smaller than atoms. Alan Turing built the foundations of computer science with algorithms and logic. Everywhere, math reshaped reality.